आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Radioactive Community Radio, Bengaluru.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
Latest information on STEM popularization.
Cells increase their mitochondrial membrane fluidity when made to respire more. A team of researchers at the Institute of Stem Cell and Regenerative Biology, Bangalore, and the University of Hyderabad studied the link between mitochondrial respiration and the inner mitochondrial membrane fluidity using fluorescence lifetimes of a molecular rota. They found that cells robustly modulate their IMM based on respiration demands. Mitochondria, or how our textbooks call them, the powerhouses of the cell, help generate energy required to fuel eukaryotic life. For this, they rely on the inner mitochondrial membrane. This membrane is packed with enzymes that form the electron transport chain, generating ATP. The cell's energy currency through respiration, ATP generation, is made possible with the help of a proton gradient that is established across the IMM. To establish this gradient, the IMM requires charge carriers to move around freely. Fluidity of the IMM should be crucial in this scenario. More fluid the IMM, more mobile would be the charge carry speed. And more mobile the charge carriers, more efficient would be the respiration.
Now, our next segment is Analyst in STEM.
Today, we are with Dr. Anand Krishna, Assistant Professor, Evolutionary and Organismal Biology Unit, Jawaharlal Nehru Center for Advanced Scientific Research.
So I am, you could broadly call me an ecologist, but the best description of my work is that I study birds. And we've also done some work on bats and frogs. But a large part of my lab is what you'd call the fields of acoustics and biomechanics. So you're recording me right now, much like you're recording me, I record birds, bats and frogs and the sounds they make. So I try to understand the physics of the sounds they produce, the ecology of the sounds they produce, and how they communicate with each other. And I also study biomechanics, which is the physics of structures. So we particularly understand how birds strike hard substances like wood and how their beaks withstand the shocks that they strike at, and what the likelihood is that they will fracture when they do tough tasks, and how their beaks actually resist breaking themselves when they're doing extremely difficult tasks. So that's broadly what we study.
So how is your research beneficial to a common man or India as a whole? And what kind of contribution is it making to the field of science in India?
Okay. So science in India specifically, I'll get to in a minute. But when I like to consider myself part of the common human population as well. And I think that our research is something that is traditionally considered looking at biodiversity, and you have orientations towards conservation, but we mostly explore our research for curiosity. But what we do with this curiosity is we understand essentially how structures and materials behave in their environment. So the same way that a bird is doing something very tough like striking onto a tree, we ourselves are doing these tasks every day in our daily lives. This is what I often call kitchen physics. Because anyone who cooks, as we all do, will often realize that many of the same things govern how we design our tools, how we work in implements, how we relate to our environment, how we build the room that we're sitting in or the buildings that we're standing in.
Yeah.
Because just like buildings are built, animals are also built. They are engineering phenomena, they're architectural phenomena, shaped by evolution. And that is something that we study that then can go on to help us understand how we build robotics, how we build different kinds of structures, how we design materials, and so on and so forth. So we actually my field tries to interface with that broadly as well. In terms of science in India, one of the things that we like to do is we like to interface with engineers and collaborate with engineers and ecologists and conservationists. So it actually is a very important interdiscipline. It brings a lot of people together.
Yeah.
And my lab actually dabbles in all of these. So we're able to actually reach across in these aisles, and we're able to advance the cause of science in India in that sense, because the courses and other things that I teach are, at least to my knowledge, taught nowhere else within the country. So in that sense, we actually, I think, bring something very new and a new way of looking at wildlife, which is not just, and because we study animals in the wild, but also in the lab, not just looking at it as, oh, there's something pretty out there, which is nice, but we also look at it as, here is something that obeys the laws of physics, obeys the laws of engineering, and we can actually learn something and build something based on that and try and replicate it and understand it better.
Yeah, thank you, sir. And the next question would be could you brief about your past, present and future areas of studies in this research?
Sure. So interestingly, my past is very recent here, because I was actually originally trained as a neuroscientist. So I was in the field of neuroscience for a PhD and a postdoc as well. And then when I came back to India, I wanted to do something different. And but my PhD, although in neuroscience, had something to do with biomechanics, because my advisor did a little bit of this as well. He was both in neuroscience and biomechanics. And when I came back to India, I wanted to study birds. I wanted to move towards studying birds out in the field. And that's where we started looking at, we look at these birds, these fruit-eating birds, groups of fruit-eating birds. And that's also where so they use their beaks to produce sounds. They use their beaks to dig holes in trees. And that's where I got interested in both of these questions. And from there, we've studied how birds, we've used sound to understand how endangered birds in grasslands are distributed and make recommendations for conservation. We've used sound to study how animals make complex signals and how they learn from each other, much like we learn from each other. If you learn something from me, then you will pass it on to somebody else. And anything that I have taught somebody passes on through social circles.
Yeah.
We study these in birds because birds learn their sounds. They're constantly learning, many birds anyway, and they're constantly passing it on through their social networks. So we work with social birds, parrots in particular, to understand how these sounds pass between networks and how they actually make complex sequences of sounds and learn them from each other. And then finally, we are now focusing very heavily on the biomechanics, which is how the structures that produce sound are actually designed and how they can withstand shocks and stresses. And we also want to understand how that same shock and stress withstanding mechanism impacts how they actually produce sound and how they communicate. Because that is also something that has a lot of engineering potential. Every time you design acoustic devices, recording devices, everything, your recording device has a shape, which says if the shape is too narrow, you have to speak right into it. If the shape is very broad, it can pick you up from very far away. And all of those designs also come in the animal kingdom. So if we understand them, we can understand how we actually design sound producing devices and other things like that as well.
So you basically concentrate about the birds and the sound that they produce, right?
That's mainly what we do. What we do. Because in the past, when I used to study bats, when I was a postdoc, we used to study echolocation in bats and other things like that. We've done some work on bats since we came here, but by and large, and a little work on frogs as well, to look at complex communication in frogs. But mainly we look at birds.
Yeah, this is interesting. It sounds really interesting. Do you have any idea about where India is right now ranked at your field of research?
There's hardly any of us doing biomechanics in India at all, or acoustics. So I would say acoustics, there's people who are studying sound. From birds in particular, there's probably less than 10 people in India altogether. And biomechanics, probably of the kind that I do, probably less than 5. And this includes my PhD advisor and other people in it. And it's a very recent field in this country. And a lot of it has been because they don't know you're not necessarily in one of the traditional disciplines of biology. People don't actually know too much about it. So we're still at the very early stages of getting this going in India. So it has a lot of room for growth. So we're still very new, which is why often when I tell people about my research, many people say I've never heard about it like that before because they've not met anyone here who does that. As I assume you have to.
Yeah.
So it's definitely a very new field and has a lot of room for growth, I think. So I'm kind of hoping that there's more of us in India in the near future.
Yeah. Do you have any ideas about the contemporaries in this field?
It's a very 20th century discipline. Both of these are very 20th century disciplines because the equipment that you needed to record any of these things did not exist until around World War II, I'll say. World War II plus or minus. Okay. And within India, the tradition goes back to the 70s and 80s of people recording sounds and recording animals in the wild and other things like that. For bats, obviously, the unit that I work in now was founded by Professor M.K. Chandrasekharan, who studied bats at Madurai Kamaraj University for many years. And his work on bat echolocation is internationally renowned. Okay. And so internationally there's a long history obviously of studies of sound and bird song and how birds learn their songs and also the physics aspects of what I do. And there are in fact even textbooks on all the subjects now. But there's also actually a fairly long history within India. It's just that there have always been very few people doing these things. And the work from India is actually quite internationally famous. So it's nice to be part of it's nice to be doing something new but also be part of a good tradition.
Yeah. So how are Indian industries associating with your research? Are there any Indian industries that are actually associated with your research?
Not currently, but I would hope so at some point or other once we get our research to a point. So what we do is we put our research up there and we hope that someone will like to actually take it forward and go back. Yeah. The companies that make microphones and other things are usually very interested in what we're using their devices for and other things because many people who make the instruments that we use never thought that it could possibly be used for this purpose. So they're very surprised when they are and they're hoping to do better. So we're hoping that this sort of picks up, of course, because my lab is relatively new as well. Yeah. But the other thing we're really hoping for is in the field of AI in particular.
Artificial intelligence, yeah.
Yeah, because we want to be able to predict sounds, you want to be able to automatically recognize sounds and classify them, and you need to be able to learn, you need machine learning in a sense in order to do that. And it has a lot of potential for our research. And it is often industrially developed, so we can hope that there's some opportunity for bilateral partnership there, which is something that we're really hoping to do at some point or other. So and one of the great things about being in Bangalore is that it's a fantastic place for exactly that. So I moved my lab here from Bhopal a month ago. Okay. So I've only been in JNC for a month, but I'm hoping that one of the great things about being in Bangalore is that there are a lot of people doing that opens up a lot of avenues.
Here we are, signing off. Stay tuned with us to catch up on the latest science updates and learn about STEM experts